and welcome back again to Elementary Algebra. I'm Amy Flicksteiner, your instructor for the course. Just as a forewarning, Ozzy is still with me. He is just a beautiful dog and my brother's, and so if you hear squeaky toys in the background or an occasional bark, you know what's going on. If you didn't meet Ozzy, he was in the last video, the last 4-ish minutes, you'll get a glimpse of him, all right? Okay, so this is section 8.2. We're going to look at some higher order roots and radicans that have variables. So the first thing that we want to talk about is a cube root. You will be seeing some cube roots in this particular course and in this setup. So a cube root is set up much the same way that a square root is. So a cube root, such as the cube root of 8, has the radical. That would be this symbol right here. That is the radical. Underneath it, we have the radicand. In this case, the radicand is 8. And then for this one, we have an index of 3. That's what indicates the cube root. So the radical is, again, that sort of checkbox symbol. You will see the radicand underneath the radical sign. The index is the 3. This tells us that we're looking for a cube root. So the cube root of 8 is 2. The cube root of 8 is 2 because 2 times 2 times 2, or 3 factors of 2. So 3 factors of 2. 3 2's multiplied together equal 8. So 2 is the cube root of 8, meaning I need 3 2's multiplied together. The product of 3 2's is an 8. Be very careful about cubes and squares. For example, the index here, that 3, makes all the difference. The square root of a negative 64, and notice I said square root, because the index is missing, we assume a square root. Our default position is the square. This is an imaginary number. You cannot take the square root of a negative number. Negatives are not within the domains of square roots. So the answer here is imaginary. However, the cube root of a negative 64 is a negative 4. Why? Because negative 4 times a negative 4 is a positive 16. But if I multiply that by another negative 4, I have a positive times a negative, which is a negative, and 4 times 4 times 4, which is 64. So 3 factors of negative 64 is of negative 4 is negative 64. There we go. Thinking ahead of myself. All right. Now, it is really beneficial to have an idea of some of the more common cubes. I have several of the more common cubes listed here. I believe I have cubes written up to 12. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. I think for myself, I don't know all of these. I think I know the first 5 for sure. And then some of them are very familiar. 12 cubed is very familiar because of all the area and volume problems that I do. 6 cubed is somewhat familiar. So it might be handy to have this list available to you. These are just some of the more common ones, looking at the cubes of 1 through 12. All right. So if we're doing the cube root, you can just look at this as the cube root of 8. The cube root of 8 is 2 because 2 times 2 times 2 is 8. But you will also probably like to know how to do it on a calculator. Now, for my calculator, okay, watch out. For my calculator, focus, focus, focus. All right. Not in the squared button. I don't want to use the squared button because these are cubes. But directly above that is the chevron key, which gives us different powers, right? It lets us take it to the third power, the fourth power, the fifth power. But above that, do you see how you've got a square root, but there's an X in the index? Where the index would be, right, where the 3 would be for a cube root, they've put an X. So what we're going to do is we're going to write a 3 with a calculator. Then we're going to shift green button, and then I'm going to get that X radical. So what the calculator is going to do is put that 3 in where the X is. So it's going to give me the cube root, and then I can just type in my 8. So it's going to give me the cube root of 8, which is indeed 2. Now, the next cube root in this particular set is 0.216. Now, I know that 216 is 6 cubed, so I'm betting this has something to do with the 6. So I'm going to do my 3, then second chevron, so I get my x root, 0.216, and I'm going to get a 0.6. For number 3, I have the cube root of a negative 1 over 1,000. You can break this just as we did the other with the square root. I can do the cube root of a negative 1 over the cube root of 1,000. It's all right to break it like that. The cube root of a negative 1 is a negative 1. Remember, negative times negative times negative is indeed positive, or is indeed negative. And then the cube root of 1,000 is 10. So this would be a negative 1 over 10, or a negative 1/10. So for number 4, I have the cube root. I can rewrite this as the cube root of a negative 8 over the cube root of 125. The cube root of a negative 8 is negative 2. The cube root of 125 is 5. So this would be a negative 2/5. The cube root of 0 is indeed 0. Because 0 times 0 times 0, 3 factors of 0 will give me 0. And the cube root of 27 is 3. 3 times 3 times 3. Right? I know some of these. Feel free to use your calculator. Okay. Can we approximate some cube roots? We sure can. I showed you where your calculator key was. Once again, you will want to use the X and then the radical. Okay. Some of you will have X, Y on yours, and that's fine too. Either one. Okay. Now let's determine if we've got an answer here. So this is the cube root of 100. Can I think of a factor that when used 3 times gives me 100? I cannot. Not 100. So I'm going to do, I need to hit my 3 first. I always forget that. 3 cube root. Then I'm going to put the 100 in there, and that's going to give me 4.64. If I do to the 100th, that will be a 4.64. Ones, tenths, hundredths. The 1 will keep the 4 low. Okay. All right, what about the second one? This is 4 times the cube root of a negative 15 over 11. So I've got a 4 times the cube root of a negative 15 over 11. Okay, so I'm going to do 4 times, then I'm going to hit the 3 cubed root negative 15. Oh, syntax error, clear. Oh, I don't need that. All right. I didn't open a parenthesis, so I can't close one. So I get a negative 9.864. That's just the numerator. And I want to divide that by 11. And I get approximately a negative, if I go to the hundredths, ones, tenths, hundredths, That 6 would bump the 9 up to a 10, which would make this 90. I need to keep the 0 in to demonstrate that I did consider hundredths place and not just tenths place. Okay, great. Now, we can find roots higher than 3. We can do 4, 5, 6. We can do 12 if we want. And all of that is just a matter of the index, right? So x, whatever this index is, that's what we want to look at. So if I'm finding the 4th root of 16, then on my calculator, I'm going to do 4x 16. And the calculator is going to put the 4 in where that x is. That's just part of its process. So 4th root, second, I got to hit the 4 first. 4 second 16. And I get 2. 5th root of a negative 1024. So I'm going to hit 5. So now that's going to make it a 5th root. It's going to put that 5 where that x is, negative 1024. And I get negative 4. 6th root, so I'm going to hit 6. And now it's going to put that 6 in as the index number, 15,625. And I'm going to get a 5. Okay. 7th root of 128. So I'm going to hit a 7. And then 128. And I'm going to get a 2. What about a 5th root of 234? So 5, 234. I'm going to get a 2.977. So this is going to be approximately ones, tenths, hundredths. That 7 is going to bump the first 7 up to an 8. So 2.98. And the 4th root of a negative 2,401. Okay, so I need a 4th root, negative 2401. I got a domain error. And when I get a domain error, that means that this root does not exist. It's probably imaginary, but we haven't done a lot of that yet. So if you're getting a domain error, just assume that the root does not exist at that index or at that particular radical. All right, great. Okay. We want you to be able to simplify roots with variable expressions, and this is all about the index. All right, so watch for the squares and the cubes and the like, all right? Here we go. The square root of 8 squared. The square root of 8 squared is equal to the square root, well, how do they... Yeah, these are all even. So one of the things that you can do here, couple of things. I'm just trying to think about how it's best to explain it. This is about the index. So the square root of x to the n is going to be equal to x to the n divided by 2. So whatever your n is, whatever this power is, if you divide it by 2, that's what the square root will be. If it's the cube root, then x to the nth power would be x to the n divided by 3. You want to take whatever your power is in the radicand, and you want to divide it by the index. Right? There's not really an explanation here. They're just having you run through it. So I'm betting that's 8/3. It is. So this is the square root of x to the 8th. So this would be the same as x to the 8 divided by 2, which is x to the 4th power. There we go. Now, when we're doing one like 16 with 2 of them, we just distribute it. This would be x to the 10 over 2 times y to the 6 over 2. This is x to the 5th times y to the 3rd. It's that simple because this is a square root. When we have ones with numbers, we simply break it apart. This is the square root of 16, which I can do, I know that one, multiplied by the square root of k squared. So this is going to be 4 times k to the 2 over 2, or 4 times k. All right, what about the 100 there? I've got a 100, m to the 6th, n to the 4th. This is going to be the square root of 100 times the square root of m to the 6th, n to the 4th. So this will be 10 times m to the 6 over 2 times n to the 4 over 2, or 10 m to the 3rd m squared. Right? Now, they made this a little bit harder because they're going to go ahead and add in some indexes that aren't squareds. And when they aren't squareds, you need to be agile enough to just switch the denominator. For example, here I have problem 19, which is the 5th root of r to the 5th. So this is going to be r to the 5 over, instead of a 2 there, we got a 5. So we're going to take the power that is divided by the index. This is r to the 1st, or just an r. Which makes sense because 5 factors of r will get us back to r to the 5th. R times r times r times r times r. I think I did 5 there. What do we do about the 3rd root of w to the 9th x to the 12th? Well, this would be the cube root of w to the 9th times the cube root of x to the 12th. It's okay if we split them up. Why is it doing this? Okay, so this would be w to the 9 over 3 times x to the 12 over 3, or w to the 3rd x to the 4th. For 21, I have the cube root of a negative 8, a to the 6th. That's going to be the cube root of a negative 8 times the cube root of a to the 6th, or a negative 2 times a to the 6 over the index, 6 over 3, negative 2a squared. Now, just for the record, if you want to check these, you can. If this is the cube root, then negative 2a squared times the negative 2a squared times the negative 2a squared, 2 times 2 is 4, times 2 is 8, negative, positive, negative, a squared would be a to the 6th. You can check them. So you see how when I multiplied it back, I got what was underneath the radicand? I did get the radicand. That's what we need to have happen, all right? Number 22, we have 81 q to the 12th. This should be the 4th root of 81 times the 4th root of q to the 12th, which will be 3 q to the 12 divided by 4, 3q to the 3. Then I've got the cube root of a negative 125 times the cube root of t to the 6th. So it'll be a negative 5. 6 divided by 3 is 2, t squared. So next we have 5, the fifth root of 32, x to the 15th, y to the 5th. So this would be the fifth root of 32, which I may or may not know offhand, times the fifth root of x to the 15th, times the fifth root of y to the 5th. So the fifth root of 32 is 2. If you don't know that, you can use the calculator. Once again, 5. Whoops. I need to clear this out. There we go. 5 first. Then I need the root of 32. That'll give me the fifth root of 32, which is indeed 2. X to the 15th. The fifth root of x to the 15th would be x to the 15 divided by 5, which is 3. And then the fifth root of y to the 5th would be y to the 5 divided by 5, which is 1. So this would be 2x to the third y. All right. Okay, if you have any questions, please don't hesitate to reach out to me or to the Math Center. Julia and everybody there is happy to help you. We did not have any barks from the peanut gallery today, although you might have seen him walk in and lay down. All right, we'll see you again next time. Thanks for coming.